I am Dr. Mahammad Rafi, Associate Professor, Department of Cyber Security at Institute of Aeronautical Engineering. Today I want to discuss about problem solving on IPV4 and IPV6 interoperability. Here is the problems, how the problems will be arise in IPV4 and IPV6. Now how can resolve those other problems? First, the problem is a address incompatibility. In IPV4, IPV6, address is incompatible. Here is the problem is why it is incompatible means IPV4 uses the 32-bit addressing. 32-bit addressing means now 2 to the power of 32. IPV4 now which is using by IPV4, but which is allowing approximately 4.3 billion unique addresses, while IPv6 which is uses the 128-bit addresses, which is providing vastly larger address space. Here is this the differences means that IPv4, IPv6 the addresses cannot be directly mapped to each other, which is not mapped to each other. The solution for this one is dual stack. By implementing this dual stack now, this incompatibility can be overcome. Why? Because now IPv6 now which is using the 128-bit address, that is a 128-bit address means 2 to the power of 128 bits which is using by the IPv6. Here this is the incompatibility. By implementing the dual stack, which allows the devices to run both IPv6 and IPv4. Even though the address incompatibility is exist in IPv4, Internet Protocol version 4 and Internet Protocol version 6 now, that can be overcome. So with this dual stack implementation, here this means the device can communicate using either protocol depending on what other devices are supported. Most modern operating systems and devices which is supporting the dual stack now, which will be support any modern operating system now, which is modern operating systems and any devices which is supporting the dual stack operations. With these dual stack operations, if is there any incompatibility, that incompatibility can be overcome. Next, the problem in a interoperability, internal operations in IPv4 and IPv6 is a NAT. That means NAT means network address translation issues. So if is there, this is the address translation issues. Why? Because IPv4 which is using the 2 to the power of 32-bit address, 2 to the power of 32-bit address, IPv6, so this is a IPv4, and if you take the IPv6 now which is using the 2 to the power of 128 bits, here IPv6 now which is using. Here the problem is NAT, network address translation, is commonly used in IPv4 network to manage the limited address space by allowing the multiple devices to share a single public IP address. Now, however, NAT which complicates the interoperability between the IPv4 and IPv6. The solution for that one is so we have to use the network address translation version 64 and DNS or domain name service 64. So these are the system services. We have to, if you utilize these system services now, we can overcome the issues in a address the translations. Here NAT 64 which allows IPv6 only. So this one which allowing the IPv6 the devices only to communicating with the IPv4, here to communicating with the IPv4 server by translating the IPv6 address to IPv4 address. If you want to translate from one configuration to the other configuration, we have to utilize the translators, that is a NAT translators. NAT, now we have to utilize the network address, the translators now we have to utilize. By utilizing these network address, the translators, now you can transfer the address from one configuration to another configuration, one version to another version. DNS 64 also, domain name service 64. So which system services also now which complements the NAT 64 by synthesizing IPv6 addresses from IPv4 DNS records. So which is enabling seamless communication between the IPv4 and IPv6 environment. That means by implementing the NAT versions, now easily we can translate the addresses. Here is the next, the problem is fragmentation and maximum the transmission unit issues. Here is the fragmentation is a one big issue, and maximum the transmission units also another big issues in a network, over the network the communication. These are the big issues. In these are the issues now what we are doing. IPv6 has a minimum MTU requirements of 1280 bytes. Now maximum the transmission requirements of 1280 bytes we can able to transmit with help of the MTU. While IPv4 can use IPv6 now, in IPv6 with help of this the protocol here, maximum translations up to 1280 the bytes we can able to transfer maximum. IPv4 can use smaller MTUs when transmitting between the IPv4 and IPv6 network. MTUs are, that means maximum transmission units will be very small. The differences in MTU sizes can be cause the packet fragmentation. That means different types of the MTUs now if we are utilizing in a IPv4, that's why the fragmentation issues will be arise, leading to reducing the which reduce the performance or even drop the packets. Here is the number of the different size of the MTUs. By utilizing the different size of these MTUs now, we can reduce the performance of the network. For that one here, now if you see the solution is path MTU discovery. We have to set the path for finding the maximum the transmission unit. In which path now we can able to transmit the maximum number of units. That is PMTUD is used to determine the maximum MTU size, which is determine the maximum MTU size on the path between the source and destination. So it adjusts the packet size to avoiding the fragmentation, ensuring smooth communication between the IPv4 and IPv6 network. Here, problems of security concerns. The security concerns are, while transmitting the data between the IPv4 and IPv6, which we have to introduce some security vulnerabilities. Network vulnerabilities will be happen, such as the dual stack networking being subject to the both IPv6 and IPv4 based attacks. The solution for this one, security best practices can be implemented. Here we have to implement the security best practices. Now if you implement the security best practices, like now security best practices are the configuring firewalls to support both IPv6 and IPv4, using the IPsecure for IPv6 and regularly monitoring and updating the operating system So that can help and mitigating the security risk during the transition. It will be help and mitigating the security risks during the transitions. And next, the problem is the application compatibility. Application compatibility means, so if you see, many applications are designed only for the IPv4 and may not the functions properly in IPv6 environment. Now the application, whatever the applications you are designed, so which is support only for the IPv4 protocol only. So which is not support the IPv6 protocol environment. Now which is leading the, so some connectivity issues will be arise. The communication now we can't establish the communication. So in these are the issues. For that now, the application modernizations and IPv6 the support can be done here. Application modernization, how it will do now, explanation, updating or modifying the applications to support the IPv6. To support IPv6, so it is a very crucial for long-term interoperability. Very crucial for the long-term interoperability. So already now we have to use the application layer, that is a gateway that can translate between the IPv4 and IPv6. These gateways, IP application layer gateways can temporarily, this is a temporary solution for that. Here is routing complexity. Next, the problem in IPv6, IPv4 interoperability, internal operations, the problem is routing problem. Now managing the routing tables which become more complex with a dual stack network. Even though if you manage these are the table, it is a more complicated as routers need to handle both IPv4 and IPv6 traffics. The solution for that one is a routing protocols that supports both IPv4 and IPv6. Here is using the routing protocols like OS PF v3 and BGP protocol. That means that support both IPv4 and IPv6 can help manage the complexity by implementing these protocols, routing protocols. Effective routing can be done. Even though bulk amount of data are transmitted over the network, with help of these the protocols, routing protocol implementation, OS PF v3 or BGP, these protocols can advertise the routers for the IP address version and simplifying the routing process. Here is slow transmission. Slow transactions also one of the issue. That means the gradual the transition from IPv4 to IPv6 can lead to the inconsistent support across the network, causing the connectivity issues. The solution is the transitional technology. Now we are using some transitional technology that can be implemented. The explanation, the technologies like 624, Teredo, ISA, TAP, these are the technologies. ISAP, 62 technologies, these can be technologies now, these are the methodologies which provide the tunneling IPv6 traffics over the IPv4 network. Here, these are the technologies now which is the tunneling the IPv4 traffic over the IPv6 network. Now easily transmit the data between the IPv6 network to IPv4 network. Here, these are all the temporary solution, and a full IPv6 adapting should be the ultimate goal for that one. By understanding these the problems and implementing these the corresponding solutions, the organizations can ensure smoother interoperability, internal operations between the IPv4 and IPv6 network. Here is the test. Here is the ISA TAP, intra-site automatic tunnel address protocol. Why it is using means now, which is the transition mechanism used within an organization network. So that is intra-sites. Intra-sites now we can use this protocol, intra-site automatic tunnel addressing protocol, ISATAP. These facilitate the communication between the IPV4 and IPV6 devices, networking devices. Teredo. So this Teredo, the purpose of this Teredo is designed to provide the IPv6 the connectivity to gadgets outdoor of an IPv6 NAT router. So it enables the IPv6 conversations even when the community the configuration is not IPv6 configured. Here the real-time applications and the corresponding solutions are high latency in online gaming. High latency in online gaming is a real-time application. So gamers generally which often they experience delay latency in a real-time or the multiplayer gaming. Take the real-time multiplayer game, leading to poor user the experience and unresponsive gameplay. So this is the problem in a real time. For that one, the solution is a edge computing and optimization. Now you can use the edge computing and optimization can be utilized. How you are utilizing this edge computing and optimization? That means by developing the edge server closer to the user can reduce the latency by processing data locally rather than sending it to a destination server. Additionally, what we are doing, optimizing the game code also. We have to optimize the game code also and the networking protocols also like UDP instead of the TCP for less overhead can further reduce the delay also. Next, traffic the congestion management. Real-time traffic the congestion management is a real-time problem. So in urban areas generally, the frequently the experience of the traffic congestions will be arise, causing the delay, increase the pollution and frustrations for the customers. These are all the real-time issues. Real-time traffic monitoring and adaptive traffic the signaling can be used for that. In this also now we are utilizing the IPV4 IPV6 interoperability. Here implementing real-time traffic monitoring system using the sensors and cameras which allow the sites to analyze the traffic patterns dynamically. With the help of the sensors and the cameras now we can scan the traffic and giving the signals allow overcome the traffic. So like this now the traffic congestions can be managed. Adaptive traffic signals can then adjust in a real time to concurrent the traffic conditions. Here is which reducing the congestions and also improving the traffic flow with the help of these sensors and the cameras. Stock market trading delays. Here also stock market trading delay also sometimes trading will be the delay. High frequency trading. So even microseconds of delay can result in a significant other financial losses or missed opportunities. Solution here, low latency the networking and algorithmic the optimization. Here is using the low latency the networking hardware and high speed the fiber optics can minimizing the delay. That means optimizing trading algorithms. Whatever the tradings now we are using for speed and speeding deploying them on a powerful other computing clusters close to the stock exchanges can further reduce the executive time, which is ensuring the quicker trades. Real-time fraud detection. Where real-time frauds will be happen means here the financial institutions. Any financial institutions faces the challenge of detecting and preventing the fraud in a real-time the transactions where immediate action is a very crucial to preventing the losses. The solution is machine learning model and real-time analytics can be used. With help of this machine learning model, real-time analytics that can be avoided. By implementing the machine learning models along with the deep learning technology, analyzing the transaction and the patterns in a real time, so that can be detect unusual behavior which indication of the fraud. Real time the analytics of the system can flag the suspicious transactions instantly, which allowing immediate intervention for the further verification, code and the completion of the transactions. Here, delayed emergency responses. Any emergency responses face the delay in reaching the scenes due to the lack of real-time information on a traffic location or the situation. So these are the problems. For that now, we are implementing the integrated real-time emergency response system. This integrated real-time emergency response system now. So this they provide the real-time GPS tracking, which is providing the real-time GPS tracking. Traffic will be updated with help of this GPS now. Traffic will be updated and the live data from the sensor. That means here via the drones or mobile devices can help dispatchers and responded choose the fastest route and prepare the accordingly. That means, for example, the best example is a Ola or Uber cabs. Here, these are all the integrated real-time emergency response systems. This improve the response time. Here, the traffic, the analysis can be done and improve the response time, and the effectiveness of the emergency the services can be improved. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.